Using service cable for parallel feeding, while technically possible, is generally not recommended, especially in a demanding scenario like a 400-meter base with 6 meters. There are several key reasons for this caution. Firstly, service cable is not specifically designed for parallel feeding applications. Typically, it consists of multiple conductors insulated with a non-metallic sheath. This construction is less suited for the requirements of parallel wiring compared to cable types engineered for such installations. Secondly, service cable tends to exhibit a higher voltage drop compared to cable types that are commonly used in parallel feeds, such as THHN or XHHW. This increased voltage drop can result in inadequate voltage reaching the meter base, potentially affecting the performance and reliability of the connected meters and loads. Thirdly, there is an increased risk of overheating when using service cable in parallel configurations. In parallel wiring, each cable is intended to carry a portion of the total current. However, service cable is generally not designed to handle the same high current loads as THHN or XHHW cables. This mismatch can lead to overheating of the service cable, creating potential safety hazards. Fourthly, inspection and maintenance of service cable can be more difficult, particularly due to its non-metallic sheath. This can pose safety risks, especially in situations where damage or insulation failure occurs, as identifying and addressing these issues might be hampered by the cable's construction. Therefore, for applications involving parallel feeds, it's advisable to opt for cables specifically designed for this purpose, such as THHN or XHHW. These cable types offer low voltage drop characteristics, are designed to handle higher current loads safely, and are generally easier to inspect and maintain, contributing to a more reliable and safer electrical installation. When implementing parallel cable runs, several additional factors should be taken into account. 1. Parallel cables must be properly supported and protected from physical damage. This often involves the use of conduit or other suitable protective measures to ensure the long-term integrity and safety of the installation. 2. The conductor size needs careful calculation based on the anticipated load and the distance from the source to the meter base. Proper sizing is crucial to ensure adequate current carrying capacity and minimize voltage drop. 3. Proper grounding is absolutely essential for safety in any electrical installation. The ground wire must be of an appropriate size and securely connected to the grounding system at both ends to provide a reliable path for fault currents. In summary, while it might seem feasible to use service cable for parallel feeding a 400-meter base with 6 meters, it is not a recommended practice due to potential safety hazards, voltage drop concerns, and difficulties in maintenance. Selecting and using cables specifically designed for parallel feeding is the preferred approach to ensure a safe and reliable electrical system.